going to have a discussion on 3D printing. You know, we've talked about 3D printing at this conference for at least 6 years, and there's been a lot of hoopla and hype, but Tali Rosman is going to ground it for us. Tali is the Vice President of 3D Printing at Xerox, and she's charge of the overall strategy, so she can help you with what's real and what's not. And she's passionate about bringing new solutions to market and really looking at how Xerox can win, not only with machines, but solutions and creativity. So Tali, I want to welcome you to the stage, and then we'll ask you some questions. So come on up.
All right. Happy Tuesday, everybody. Thank you for having me here. So I'm Tali. I'm the General Manager and Vice President of Digital Manufacturing and 3D Printing at Xerox. And really, I want to talk to you about how 3D printing can help the supply chain. Yeah, so I think one of the things that already came up just as we were starting the day is how there were so many disruptions to the supply chains in the last year and a half that almost the unnormal and the disruptions became the new normal. It's everything from COVID to ships being stuck in the Suez Canal to hurricanes and natural disasters. So it's been really hard. And it was actually interesting. We at Xerox, we did a survey among supply chain leaders. How would they rank their supply chain before COVID and after COVID? And the results were staggering. Before COVID, I think we had over 70% give their supply chain an A or a B. And it was the exact mirror image. 70% gave it C or below after COVID. So it's clear that there's a lot of disruptions, and a lot of you as supply chain leaders have to be ready for it. And this is where 3D printing can come in as another tool in your toolbox to help build that supply chain resiliency that was mentioned. So 3D printing has a couple of great benefits. The first one is that low volumes are made economic. Okay, with traditional manufacturing, there's a lot of economies of scale, right? You start reaping the benefits when you make 100,000 units a year, 200,000, a million units a year. What about when you have low volume? Low volume either because you have a supply chain disruption and you just need a low quantity to get you through the 8 weeks until the ship is released or the plant that was hurt in a hurricane is back up and running or what have you. So 3D printing makes low volume economic and can really do a great service. And with that, you don't have all the setup cost. You don't have the tooling. You don't have the mold. If you have a 3D printer, and you have the design, click and go. I know that my machine operators are gonna, cringe now and say, well, it's not exactly like that, but it's almost like that. If you have the design, you can get it up and running on the same day and get the part in your hands in a matter of hours. The other great benefit of 3D printing is the freedom of design. So you can make geometries that you couldn't make before. There are some obvious benefits here. You can get the same part with the same material properties, but reduce the weight. Obviously, in certain industries like aerospace, electric vehicles, that's a great benefit. But the really great thing about the freedom of design and the ability to make geometries that you couldn't do before is that you can take what was once full assemblies and 3D print them in one go. So there's endless case studies online. One of my favorite is Jabil, the large contract manufacturer, took a part of a cooling fan that was 73 different parts and 3D printed it in one part. So imagine the implications to your supply chain. Instead of having 73 different parts with 73 different SKUs that are coming from 12 different suppliers and managing all these suppliers and doing demand planning for each of them and eliminate all that and be able to do it in one go. Okay, one part instead of 73, one SKU to manage, and you can 3D print it in a matter of hours instead of accumulating inventory. I mean, today you're faced with two pretty bad options, right? The first option is build a lot of inventory, which costs you tens of millions of dollars in warehousing costs, and spend a lot of money to make sure that you always have the part that you need. The alternative is to take a risk and then be left caught off guard. One of the things that was mentioned in the previous session was about that nobody ever in supply chain starts with the customer. They start with the supplier. I think you were saying that. I found that very interesting and very true. To me, the supply chain is what is the impact on our customer, right? How do you quantify the fact that the customer has been waiting for 8 weeks for the part? Like, what's the benefit of you being able to 3D print, give them the part in a day, instead of making them wait for 8 weeks? With 3D printing, you can do that. So these are really the benefits of 3D printing, which kind of raises the question, well, 3D printing is so great, why isn't everybody using it? And I know at the end you're supposed to ask me questions, but I actually want to ask some of you guys how much you're using 3D printing to overcome your supply chain challenges. And I bet you the answer will be that a lot of you are not using 3D printing enough to overcome supply chain challenges. I think there's multiple reasons for that. One is exactly what was mentioned, is how do you quantify that value to the customer, right? The fact that the customer gets the part in 2 days instead of waiting for 8 weeks. Another one is just, pure technology, right? I think a lot of the 3D printing technologies today are pretty hard to use. They have a lot of, let's call it tribal knowledge that is associated with them. There's a lot of requirements. It's not plug and play. Certainly you're seeing that trend with certain 3D printing companies, Xerox included, the trend to try and make it as much plug and play as possible and automate things instead of, I think you were saying in Schneider Electric, instead of having those pockets of tribal knowledge, making it easy and automated. But I think the other thing is changing the mindset. There's a lot of things that need to change in supply chain operations in order to reap the benefits of 3D printing and making it more attractive and more appealing. So the first one is distributed manufacturing, right? What we want is to get the part, is to have the certainty that we're going to have the part that we need when we need it, where we need it. Just because you have a lot of inventory in your centralized facility doesn't mean that you're going to be able to get it in the hands of the customer. Again, one of the things that I was mentioning in the opening speech is the shortage of truckers, for example. And again, we talked about the ship in the Suez Canal and international shipping, but also domestic shipping, again, with the trucks is an issue. So with 3D printing, because you don't have the economies of scale that you do with traditional manufacturing, because you don't have the expensive setup, the toolings, the mold, you can just have one printer in a place, you can strategically place 3D printers in your different facilities. In the case of Schneider, across your 200 facilities, place one in the East Coast, and the West Coast, and the Midwest, and the South, blah, 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 so you can get the part that you need when you need it, on-demand manufacturing with 3D printing, but also where you need it. And thereby, instead of thinking, how do I optimize my shipping, what if we took that risk off the table by using distributed manufacturing? Obviously, I don't need to tell you guys, this is a big mind shift change, going from a centralized thinking and centralized facility to strategically placed 3D printer to deliver distributed manufacturing. We also have to change the focus from unit manufacturing cost to total cost of ownership. Those bars that you're seeing actually represent a real example of a part in Xerox. It's for a bracket that we wanted to move from metal casting, which is how they asked us what's the cost. They said, but we get it much cheaper from our supplier. That's the green bars. And that was true until we double click and we asked them, okay, but from the metal casting vendor, do you have minimum order quantities? Well, yes, we do. Okay. That specific part has a demand of 300 to 500 a year, but you got to order at least 1,500, which means you're ordering a lot more than you need, and then you have to store it in warehousing for 5+ years until whenever you're going to use it. So we said, okay, what's the cost to Xerox of spending that cash up front? What's the cost of the warehousing and inventory that's associated with it? What's the risk of needing to scrap that at the end? That we bought too much. We don't need it. It might not last all these years. So we started accumulating this. We actually developed a really nice calculator tailored to our needs to start doing it. And when we did that, we actually saw that 3D printing makes a lot of sense. It actually became the cheaper option. However, that team is measured on unit manufacturing cost. That specific team is measured, and I'm seeing some nods in the audience, they're measured on the green bars. So we all knew this part makes a lot more sense. Laid out the full business case, but at the end of the year, I gotta look at the green bars, and I gotta explain why I didn't buy it from the metal casting, why I moved it to be 3D printed. So that's another big change management aspect, is how we measure our people on it. The freedom of design I talked about. This shouldn't be apples to apples. This shouldn't be, hey, this is the part that I want. I used to metal cast it. Can you 3D print this design? Well, I can certainly do that, but I can do you one better. because I can optimize the design, again, I can reduce weight, I can reduce material waste. By the way, for those companies that have a commitment around carbon footprint reduction, like we do in Xerox, and I'm sure a lot of the companies here have the same thing, that really comes into play. That bracket I was mentioning, we're saving 43% of the carbon footprint by 3D printing it instead of metal casting. And this just is a kind of a side benefit. But part of it is certainly because we redesigned it to reduce the weight, reduce the material usage, and there's no scrap. And again, as I was saying, lightweighting is one thing, consolidation, that's the really great thing. Again, that example I gave, the ability to take what was 73 parts from 12 different vendors, one part, one vendor, one SKU, making it much easier. And the ability to make that one SKU on demand. You know, you guys were talking in the beginning about the demand planners. Well, you can get a lot of efficiency there. Once you have on-demand manufacturing that allows you to, you know, take the volatility and be able to address that volatility pretty easily. So DFM is an important thing that has to change. And integration into existing manufacturing workflows. So when I started in the 3D printing industry, it's almost 10 years ago, we had kind of this vision, and I was definitely drinking the Kool-Aid. I'm a lot more sober now and much more data-driven than I was then. We're all drinking Kool-Aid and thought, 3D printing is going to take over. You know, everything will be 3D printed. Well, no, it's not. We all know that now and we all acknowledge it. So 3D printing today is 0.1% of the global manufacturing pie. You know, I think that if we do all these changes, and of course, yes, the technology has to be easier to use, the material range has to grow, kind of all these things, but if we do all these changes, 3D printing can certainly get to 10% of the global manufacturing pie. Be 100x what it is today, which would be amazing. But even if it's 10%, that means 90% is not 3D printed. It's still the minority, which means we have to integrate into existing manufacturing workflows. We've had a lot of kind of siloed systems in the industry, and I worked with quite a few companies in this industry. We had siloed solutions. I think now is the time. If 3D printing really wants to become a viable mainstream option, we have to tap into the existing manufacturing operations. We have to get out of the additive manufacturing lab that, you know, sits in a little silo with separate systems and be part of it. And that needs to be across the board. If you want to rely on 3D printing as your backup generator, so to speak, when you have a supply chain disruption, then like a backup generator, it needs to be on when the time is right. To do that, there's all these steps that you have to take before. One of them is the qualification, right? If you have now a supply chain disruption and you want to 3D print that part that you're missing in your machine, normal operations, you know, take a month or 2 months, however long it is to qualify a part. Well, okay, by then your supply chain disruption will be resolved. The ship will make its way back and you're fine. So you have to think about these things in advance. And as you're designing the part, as you're looking at your parts repository, think in advance, how can I pre-qualify these parts such that I'm comfortable using the 3D printed version of those? So when you do that, and when you have a digital repository of your part, and the part is certified to both be made with metal casting or injection molding or however you're making the part, and with 3D printing using this specific technology, you have assurance that, again, when the time is right, when you have a supply chain disruption, in the design process, we got to develop a lot of better tools around the inspection, around quality. And you're seeing that in the industry, right? You're seeing both 3D printing OEMs, like Xerox getting into it. You're also seeing a flurry of startups that are starting to develop these tools. And I really think that companies can reap a lot of benefits from using 3D printing in their supply chain operations to build that resiliency. To know that you can always get the part that you need, when you need it, where you need it, and without needing to build tens of millions of dollars worth of inventory and worry about the shipping and all. So just to summarize, I think that if we as an industry, again, we as an industry have to tick our own boxes. We got to make sure the technology is reliable, repeatable, we have the material selection, we make it easy to use. You guys from your side have to make those changes that we discussed. Think about distributed manufacturing. Look at total cost of ownership. And in the total cost of ownership, if there's a way to quantify the customer experience and the ability to give the customer faster part in hand, how much is that worth? Be open to design for additive manufacturing. to change the design and optimize it. As a side comment to DFAM, it's not just about DFAM, design for additive manufacturing. It's also the ability to make the same part with another material. So one of the customers we're working with, so our printer works with aluminum, but one of the customers we're working with, they're looking at a really legacy spare part. This part is more than 50 years old in its design, and they're only using a handful of it a year because it's truly, truly, truly end of life. So that part was made with zinc up until now, but they looked at the material property and said, actually, you know what? Aluminum is good enough. So it's DFAM, but it's not just that. It's also opening up to, not how did I used to make this part and the properties that I got, but really what are the properties that I need? What do I need and what is good enough for me to be able to rely on it? And again, the integration into existing manufacturing workflows, which I think is kind of a combination of a printer OEM and the customer. And I think that if we all kind of work together on that, and I'm really looking forward to the discussions, to hearing, again, which one of you is using 3D printing? How did you adopt it? Where were the challenges? I think 3D printing can kind of live up to its potential and go from the 0.1% to 5% and maybe all the way up to 10%. And so happy to follow up with anybody kind of on that, and very curious to hear your experiences. I intentionally went through the presentation because the discussion was really great. So I wanted to leave sufficient time for that.
And I love that. So let's bring on some questions. Tali, tell the group a little bit about your group at Xerox and what your mission is.
Absolutely. First of all, Xerox has been in the 3D printing industry in different forms and shapes for the last 20 years. From, obviously printhead technology, software projects down at the Park, our Palo Alto Research Center for customers like DARPA and NASA and the likes, a lot of material research. But it was only kind of a couple of years ago that Xerox really decided to, all these research projects and all these onesies, twosies, to take it and make it into a true business. So we're set up in Xerox as a separate kind of autonomous business unit, so we can run fast, big things. And our little startup is actually not that little. We're close to 100 people now.
Congratulations.
And, it's very, very exciting things and moving fast.
So if people need feasibility analysis on 3D printing, they could call you?
Yeah, definitely. We developed those tools actually initially for Xerox's own purposes. So about a year ago, we started in Xerox what we call, printing what we preach, which was the nicer name to eating our own dog food and using 3D printing in-house. And as part of it, we did overcome a lot of the objections that we saw. Well, what's the total cost of ownership? How do you qualify the part? How do I know that when you 3D print me this bracket for the digital press, it's actually going to work? So we had to develop all these tools in-house, and what we're doing now is we're making them accessible to customers as well.
Tali, as you were talking, lots of images went through my mind, right? I remember when I used to write about supply chain disruption for the holidays, we'd have 21 ships off of the port of Long Beach. Today we had 45. So our holiday period, there may not be Barbies under the tree or great little trucks for kids, but this concept of 3D printing to be a backup generator, right? Hurricane Ida came through Pennsylvania where I live. I ended up with 8 inches of water in my basement, but wow. I had an electric generator. And that electric generator cuts on every Sunday. And if that generator hadn't been there, I'd probably had 2 feet of water in my basement. But if we think about this process for Supply Chain 2030, we got 2D drawings, we don't have 3D drawings, we don't have additive mindsets. How do we get to the point where we can have that analogy to work?
It sounds like I ordered that question. No, so I agree. One of the things we saw, at least at Xerox, is, and certainly we're seeing it with a lot of customers, especially for the legacy spare parts, all you have is a drawing. You don't have the CAD file with all the metadata. By the way, sometimes you don't even have the drawing. Literally all you have is like that part that got left behind, and can you make me one of those?
Can you make me one of these? And they take out a little...
Yeah. Exactly. So we've actually partnered with a couple of companies that are specializing in it to do these conversions. So we're, kind of like Xerox was the documents company and was the first one to digitize documents. We're now digitizing parts inventories as well, working with our partners that have developed really interesting technologies to take the drawing and convert it into a CAD, have the metadata, and then do the analysis.
But it has to be 3D, right? Not 2D? I can't use the conventional drawings.
Yeah, you can't take a drawing today and put it in a 3D printer, nor can you put it in a decision engine that will tell you, oh, is this part printable and how much it's going to cost you. You have a prerequisite that you have to take the drawing and convert it into a 3D. And it's why, again, because we went kind of for all these challenges internally in Xerox, we had to figure out either how to develop it or find partners that know how to do it, which in the case of a drawing into a 3D CAD, we found a great partner that's working with us, and we're fully digitizing repositories now.
But this additive mindset, Jabil talked at the 2017 conference about the additive mindset of what they're doing, and that their customers just don't have the additive mindset. How do we build that additive mindset? Because the gap between production planning and manufacturing and product development is so large, right? Product development to manufacturing, quality design to quality of conformance, a big bridge to cross.
Absolutely. So I think it's two things. I think one is we as an industry, we have to offer tools that make it easy. If we leave it to rely on kind of the tribal knowledge of a few experts, it's not going to scale. So we as an industry, and again, you're seeing kind of a flurry of startups in this domain that are starting to automate that tribal knowledge and make it really easy. Second thing is today in universities, and certainly we partner with a few of them, in the last 5-6 years, anybody that studies engineering also has an additive manufacturing course. So a lot of the people coming now into the workforce and people coming in the last few years are coming with that additive mindset. So I think you're going to see kind of what the Schneider Electric story was, is there'll be certain environments with a lot of people who studied additive manufacturing in university, got hands-on experience in additive manufacturing labs at their universities and are coming only for it. And you're going to see the plants that have been running for many years and don't necessarily have that mindset. And you'll have to probably infuse people with that mindset into these environments.
Well, and maybe we partner with the universities to come and teach that class to supply chain professionals, right? Because we don't have that additive mindset. I think most people would struggle with what's a 3D drawing or image look like and what's required to feed a machine for that backup kind of capability.
Yeah, and I think a lot of it is, and certainly, what we're trying to do as a side comment is to give the power to the supply chain people. So I think that if we develop tools that make it easy, and the power can be in the hands of the supply chain people to know very easily, what are my options of getting this part produced? Can this part be 3D printed if I need to? How much is it going to cost me? How fast can I get it? And then weigh the options. The easier we can make it in supply chain people and give them the ability to do it without relying on favors from engineering, I think the easier it'll be.
So let me give you a magic wand, 2030. You got the magic wand. What does 3D printing look like by 2030, and what is the role of 3D printing in the manufacturing composite of the supply chain for 2030?
So I think for some parts, 3D printing is going to be the default form of manufacturing, especially low volume part, either low volume again because they're in industries like aerospace, or because they're kind of end of life, products that are becoming low volume. So 3D printing is going to be how you make the part. And for other ones, it'll just be used as a backup generator, meaning if everything is fine in your supply chain, you can get it from your metal casting shop in China, great. But if now you have a disruption, kind of like what you had in your house, and sorry to hear that, hopefully everything is fine.
Well, we'll get it when we get back, right? I get to talk to a lot of repairmen.
So kind of like what you had as a backup generator, which is kind of the scenario where you hope you never have to use it. Mm-hmm. But when the time comes that you do, you're mighty happy that you have a backup generator. And even if, again, you bought the backup generator and you don't use it for 3 years, you're still very happy that you have it.
And it's got a green light on it, and every time I drive in the driveway, it says it's ready. But we don't have that capability in the supply chain. Let's run some mics. Rick and Regina, what questions we have? Okay, right there Let's state your name and your company and bring on the questions.
Yeah. My question was, you're talking about kind of like backup generator. Are you trying to influence the design of products the same future or safety manufacturing?
So that's a great question because, to your point, a lot of the kind of cost and the manufacturability of a part, they kick in really early in the design phase. So I think there's two parts to the answer. The first one is for new parts that are going to be designed now. I think, yes, the additive design should be factored in.
Maybe in parallel, right?
Yeah, kind of a side by side. I think for the legacy spare parts, that's kind of a different challenge because you're kind of confined by what you can do because that part has to fit into an already made assembly, and there you're going to have maybe fewer opportunities to optimize. But certainly for new parts, I think kind of DFAM and thinking about the whole assembly can add a lot of value.
Great question. Next question. Yes, hi. Name and company, just for the audience.
Hi, this is Harsh Kapula with CGN Global and Tada Cognitive. There's two different companies, actually. But the question is this: would adoption become much faster with 3D printing if we could have a service, 3D printing as a service, which is, sort of a national grid used very quickly, as opposed to companies individually building the expertise like you have over a long period of time?
So,
sort of what is the state of that industry now in terms of what's capable?
What do you think it'll be in 2030? Will we have digital printing as a service?
Yeah, so certainly you're seeing now service bureaus that are specializing in 3D printing and have several different 3D printing technologies emerging exactly for that purpose, to save companies the need to bring it in-house and figure out how to do it, etc. I think one of the challenges with that, and by the way, a lot of those are kind of becoming very successful. You can look at companies like Protolabs and Fathom and Xometry and others that are really gaining traction in the market. But I think one of the challenges with that, and you guys know this better than me, is you need to qualify these service bureaus and you need to qualify these technologies and get a sense of comfort with them. The other thing is, if you're going to use 3D printing as a backup generator, then like a backup generator, you want to know that it's available for you 24/7 without needing to now go to the service bureau. So I think as I'm looking kind of forward and thinking ahead, I think it's going to be a hybrid environment. I think there's going to be certain capabilities that you're going to want to have in-house because, again, a backup generator you always want to have in-house just in case. But then I think a lot of parts you will be potentially taking to a service bureau externally in case you don't want to keep the machines and the CapEx. And I think it's going to be more of a CapEx question. I think today a lot of it is also because a lot of the 3D printing technologies are cumbersome and complex to use. So you kind of have to go to a service bureau if you don't have the expertise in-house. I think that will gradually go away as technologies become easier, and then it'll really be kind of a CapEx versus OpEx question.
But we have to design for it.
Yeah.
And we have to qualify for it.
Yeah.
And we need the ability to rationalize when to move to the backup generator in sales and operations planning and our planning processes. So there's a whole lot of governance and process I think we need to think about that doesn't exist today. We don't have 3D drawings. We don't have qualifications, right? It's sort of out there like, yeah, maybe, but it's not mainstream.
So 100% agree. But I think in 2030, I think almost every company will have its parts repositories digitized. Again, I look at 20 years ago with documents, everything is digitized. In Schneider, they were saying paper is almost going away completely. You're going to have the same thing with parts. I have no doubt that in 2030, parts repositories are going to be digitized with the 3D models, with the metadata, both for new parts that are being designed now, but also companies are going to go back and digitize their legacy spare parts. I think once it's all digitized, then there's a lot of tools in the market today that can run on a digitized repository and tell you all the parts that can be 3D printed. Simulation tools, which will give you what is the expected quality, are becoming much, much better. And certainly we're in 2021. By 2030, I think they're certainly going to be in a different place than they are now. So yeah, I think it's kind of that prerequisite of the digitization that has to happen in order for you to be able to enjoy all these tools.
But we've got to close the loop between product development, manufacturing, supply chain, and that alignment really requires a lot of leadership. So, other questions?
Laura, we have one here.
Yeah, one right here, yeah.
Hi, it's Steve Vilmoney. I'm a consultant. 3D printing or some form of 3D printing years ago at Ford. And we were changing a design on the F-150, and we had 2 weeks to get something done. And they had this thing they called stereolithography that we used to make molds for the casting. The thing that, hearing you talk about this, using 3D printing for maybe not to make the part, but to make the molds or make the so, for a plastic mold, make it out 3D print it versus machine it.
Yeah, so I think it's a great point, right? I was saying it's 0.1%. That's kind of when you look at end-use parts. Today in prototyping, estimation is 30 to 40% of prototypes are actually being made with 3D printing. So, certainly in prototyping, which again, I said 3D printing, you have the benefit of low volume made economic. Obviously, if you're prototyping, that's low volume by nature. And secondly, with prototyping, the rapid turnaround time is critical, which again, 3D printing has a massive benefit over anything else. So again, in prototyping today, it's completely mainstream. In end-use parts, for all the various reasons we mentioned, it's again far from mainstream. And I think, again, we're going to see it more and more.
Okay, one more question, and then we're going to transition. Yeah, Alex?
Thank you, Tali. My name is Alex Wisniewski. I'm with the Digital PMO Group, and I thought the statistic you just mentioned that the 0.1% of global manufacturing is made up of 3D printing. In your opinion, how long will it take to get to for 3D printing to get to 10% like you mentioned? And with the sustainability piece in mind, should this be expedited, kind of taking into account the 2015 Paris climate goals?
Great question. So first of all, and when we're going to get to the 10%, 3D printing was all the hype. We thought it would be in 2020. So
I heard 2015, and so why didn't we make 2015?
No, so I think it's a host of the reasons that I mentioned. Right. First of all, I think the technology wasn't good enough yet. I think repeatability, reliability, the materials range, so really the ability to give you that comfort that the part will work and function as desired. I don't think we as an industry were good enough yet. And secondly, I think we still have to get through the change management. I think, though, the last year and a half created this compelling event that is forcing companies, to really look at that. So I do think by 2030 we're going to get there. And I do think also things like the carbon emissions, because certainly 3D printing over traditional manufacturing generates massive carbon footprint reductions, especially even more so if you use it in distributed manufacturing. And the more companies and governments start assigning a dollar value to it, that will make the business case for 3D printing much easier. So certainly I think that's going to be another nice push.
Thank you, Tali. Let's give Tali a hand.
Thank you, guys.